Good morning, all. Welcome back to our course on Introduction to Computers and the C programming language. In today's session, I'm going to discuss about one of the important concepts in C programming language, that is control statements in C. Before going to discuss these control statements and what are the various constructs that are available under these control statements, we need to discuss one important point, that the execution of C program will be in a sequential fashion. We'll see what this sequential, or we can also say it as a linear fashion. But the most appropriate word is the sequential fashion. So whenever you start executing a C program, let us take an example C program xyz.c, which consists of some 5 statements. Let us take the entire program consists of only 5 instructions or 5 commands or 5 statements. When you press Ctrl plus F9, that means when you start executing this program, the execution always starts from the first statement, and after executing the first statement, it will go and execute the second statement. After second statement, it will execute the third, then fourth and fifth. So this is how the execution of C program happens. That means the execution is going to happen in a linear fashion, one after the other. It is going to happen in a sequential fashion. So in general, any C program executes in a sequential fashion. This is what I want to stress. But this may not be the case in all the situations. For example, programmers are intended, or the programmer wants to write some programs where he wants to execute some instructions based upon some conditions, right? Based upon some conditions. And in some other situations, he wants to repeat, the programmer wants to repeat some set of instructions for n number of times. These are the situations what a programmer may come across. One is, he may want to execute some set of statements based upon some conditions, and he may want to skip some instructions if the condition is false. Similarly, he wants to repeat a set of statements for n number of times. In these two situations, the programmer is going to violate the sequential fashion execution of the C program. So every statement is not executed. Every statement is not executed in a sequential fashion. For example, if the condition is true at statement 2, he may directly go and execute the fourth statement. The program has to be written in such a way. And in other situation, the programmer can write some set of statements, this block of statements 2, 3 and 4, to repeat these statements for n number of times. This is very much needed by the programmer if he wants to write some dynamic programs, or if he wants to write some interactive programs. So to get into this situation, or to handle such type of problems where the programmer is free to write some code based upon some conditions, that means he wants to execute some set of statements if the condition is true, and if the condition is false, he wants to do something else, or if he wants to repeat something. In these situations, the C programming allows us to do or to write programs with these two situations by making use of the control statements. So once we are well equipped with what and why we require these control statements in C, let us see what are the different types of control statements we have. The first type of control statements what we have is decision statements, and the second type of control statements is the looping statements. This terminology is very important. Loops are nothing but repetitions. As we have discussed in the above discussion, that whenever the programmer wants to repeat some set of code, then he can make use of the looping constructs that are available in C to repeat those statements. Similarly, as I told in the earlier discussion, that there are some situations where you need to execute some statements based upon the conditions. So you will be deciding whether to execute some set of statements or not. Those are called as decision control statements. So these are the broad classifications of the control statements that are available in C. Now let us go deep into these classification. Into how many types the decision has been divided, the decision control statements has been classified, and similarly into how many parts the looping constructs has been classified. Let us go with the first one, the decision part. The first construct that is available based upon the decision statements is if. We'll see all the syntaxes and what happens and how it is going to execute. All these things we will discuss. But the classification is, the first classification is if, and the second one is if else construct, and the third one is nested if construct, and the fourth construct is if else if ladder, and the final one, which is very important, is switch case. So these 5 are the different constructs that are available for a programmer in C programming language to make a decision control statement. When we go to the classification of the looping constructs that are available in C, we have basically 3 different constructs that are available. That is the for loop, next we have while, and next we have do while. So these are all the 3 constructs that are available under the looping constructs. When you want to repeat some set of statements, either you can go with the for loop, or you can go with the while loop, or you can go with the do while loop also. Now we are clear about how the C program is going to execute. The C program is going to be executed in a sequential fashion, and there may be some situations why we require these control statements. There may be some situations where the programmer is free to make some decisions, and he is free to execute some set of statements based upon the true condition or the false condition. Similarly, there is another situation where the programmer can repeat some set of statements. In such situations, the C programming language allow 2 types of the control statements. One is the decision control statements, the second one is the loop control statements. Under decision control, we have again if else, nested if else if, ladder, and the final one is switch case. And similarly in the loops we have for while and do while. So this is all about the introduction part related to the control statements. So in today's session what we will do is we will simply go with the decision control statements, and in the next session we will be discussing about the looping constructs that are available in C. And all these 5 constructs we will be discussing in today's session. Let us go with the first construct that is available in C, that is simple if. We can call it as if construct, or we can add the term simple if also, nothing wrong in it. Let us take the syntax of the if else statement. The syntax of if construct is very simple, that it starts with a keyword called if, and after this keyword we start a parenthesis and close, and within the parenthesis you should specify some condition. And after this condition you have to give the body of the if statement. As we know that the body of any construct in C can be specified with a pair of curly braces. The left curly brace indicates the starting of the body of any construct, and the right curly brace indicates the end point of any construct, right? So here you can observe here that there is no statement terminator for this if condition or if construct. You should not put any condition over here. You should not put any statement terminator here. Semicolon is completely avoided. And let me discuss something about this condition. The condition specifies the Boolean value. So whatever you specify here as the condition, it should evaluate a Boolean value. That means either it has to be true or it has to be false. So you may get a doubt that what are these conditional statements? What are the different types of expressions we can take under these conditional statements? The different conditional statements that we can take under these conditional statements is, you can take some arithmetic expressions, or you can take some conditional expressions, or you can take some logical expressions, or else you can take the relational expressions also. Any type of expression that finally evaluates to be either true or false is considered to be taken under these condition statements. So the syntax of if statement starts with if keyword followed by a condition that is specified within the parenthesis, and you have to write the body of the if, which includes any number of statements. You can include. Like this. Let us see how this if is going to be executed. Let us take a simple example. Int a is equal to 10. And I want to execute a statement that whether it is the value that is taken is positive or negative. So I take a if condition, if construct, and the condition is, how do you represent whether it is a is positive or negative? If a is greater than 0, it is considered to be a positive value, and if a is less than 0, it is considered to be a negative value. This and all we know. So if a greater than 0, I start the body of if and I write a simple statement printf, the value is positive. Very simple program. So I have taken an integer variable a and I have assigned it to a value of 10, and here I am checking whether if a greater than 0. What is the value of a? We have 10. 10 greater than 0 is true. You can see here that a greater than 0 is a relational expression. So relational expressions are accepted, logical expressions are accepted, arithmetic, conditional, all these expressions are accepted to be written under this conditional statement. So 10 greater than 0 is true, that means it evaluates to true. Therefore, if the condition is true, it is going to execute the body, this one. So it will enter into the body of the if condition, then it will print this statement. The output what we will get is the value is positive. This is the statement that is printed as the output. Now let us modify the same program. Let us give the statement as a less than 0. Instead of a greater than 0, I am writing it as a less than 0. If a less than 0. When you start execution of this program, we know that the a value is assigned to 10 and 10 is less than 0. This is false. Whenever the condition is false, the body of the if is not going to be executed here. Therefore, it will not enter into the body, and therefore it will come out of this if constructor, and it starts its execution from the statement which is present after the closing curly brace of the if body. But there are no statements here. Therefore, it will simply execute the program with no output in this case. This is how the if is going to be executed. The only thing you have to remember is if followed by condition. If the condition is true, then the body of the if is executed. If the condition is false, the body of if is skipped from the execution, and the execution continues from the next statement which is present after the closing curly brace of if block. So in this case, if the condition is true, the statements 1, 2 and so on up to n will be executed, and after executing the entire if body, it will start its normal execution in a sequential fashion from the statement outside of the if body also. So if the condition is true, it is going to execute this one, statement 2 will be executed, all the statements in the body up to n will be executed, and once it is completed, it will execute the n plus 1, it will also execute n plus 2 and so on. But if the condition is false, the body is not executed. The body of if is not executed. Therefore, statement 1 will not be executed, statement 2 will not be executed, and all these statements up to statement n will not be executed. So the execution of this if body will be skipped, and the execution continues from the next statement that immediately follows the if construct. That is, statement n plus 1 will be executed, statement n plus 2 and so on will be executed. So this is how the if statement is going to be executed. Very important and simple construct. Now let us move our discussion to the second construct of the decision control statements, which is if else. If else construct. Let me write the syntax here. The syntax of if else is almost similar to that of the if construct only, but we are going to add one more keyword and one more block to our construct, which is called as else block. So the syntax starts with the keyword if followed by the condition, and after that we have the if block, that is the body of the if will be there. So here you can have some statements, statement 1, statement 2, statement 3. In this example I am just taking only 3 statements. This is generalized example, but I am taking 3 statements that exist in the if block. And after closing this if block, you have to write one more keyword, which is else. And then you have to start the else body also. Let me take 2 more statements in the else, statement 4 and statement 5. And after this, let me write the statements, statement 6 and statement 7. This is for an example purpose, right? So the syntax is if followed by the condition and followed by the body of if, and then we have else block, else keyword followed by the body of else, and then we have number of statements that constitute the program. Let us see how it is going to be executed. As we told, the condition is always the same. It can be a logical expression, or it can be a relational expression, or it can be an arithmetic expression, whatever it may be. But it should always evaluate to be the true condition or the false condition. Only 2 things should happen, true or false. So if the condition is true, it is going to execute the if block. From here to here, we can call it as the if block. There is other name for the if block also. So this is also called as true block. Why? Because this block is going to be executed. The statements of this block is going to be executed if the condition is true. Therefore, we can name it as true block also. But what happens if the condition is false? If the condition is false, the if block or the true block is not going to be executed. It is going to execute the else block. So from here to here, we call it as the else block, and we call it as, we can also call it as false block also. Why? Because if the condition is false, this block is going to be executed. Therefore, we call it as false block. Right. So let us see what happens if the condition is true. So if the condition is true, it is going to execute statement 1, statement 2. This is statement 1 is executed, statement 2, statement 3 will be executed. And after executing the true block, it will jump out of the if else block, and it will start its execution from the next statement, which is present as the first statement of the if else block, statement 6, and then statement 7 is also executed. So if the condition is true, it is going to execute 1, 2, 3, 6 and 7. Let us see what happens if the condition is false. If the condition is false, we know that the true block is not going to be executed, but the else block, which is also called as the false block, is going to be executed. So if the condition is false, statement 4, 5, 6, statement 4 and 5 will be executed. Once the else block is completed, it will go and execute the statements out of the if else block. So statement 6 and 7 is also executed. So these 4 statements constitute the execution of statements if the condition is false, and these 3 statements along with the statements 6 and 7, these 5 statements are going to be executed if the condition is true. This is how the execution of the if else is going to take place. Now I'll try to give a simple C programming example to justify this if else statement or if else construct, to illustrate it. So I start my program with the main function. This program is to check whether the number is even or odd. So I will take a number. Let us take a integer variable int x is equal to some 5. Now I will check if x modulo operator 2 is equal to 0. So what is this modulo operation? We know that this modulo operation is the remainder operation which gives the remainder when x is divided with 2. So if it is exactly divisible by 2, we call it as the even number, and if it is not divisible by 2, we call it as the odd number. So here what we are going to do is we will take a number and we will find the remainder when it is divided by 2. If it is equal to 0, then we print it as even number. Otherwise, we have to print it as odd number. So if it is true, if this is true, then I have to print it as even. And if this condition is false, so if the number is not exactly dividing, if 2 is not dividing exactly the given number, then it becomes odd. Very simple program. So I have taken 5 modular division by 2 is 1, that means the remainder is 1. Therefore this condition evaluates to false. It is going to be evaluated to false. If the condition is false, then false block is going to be executed. Therefore else block is executed and we will get the output as odd. Very simple program to illustrate the concept of if else. Now let us discuss the another conditional construct that is available in C, that is nested if. Here you should observe one important term that is related here, that is nesting. So nesting, anywhere you find in C programming language or any language in any programming language, when you find the term nesting, it is something we are putting one inside another, right? So nested if means one if inside another if. Nested for, one for inside another for. Like that, when you include one body inside another body, or one entity inside another entity, or one construct inside another construct, such type of things we term it as nesting. So here nested if means one if inside another if. Very simple thing, right? Let us see what is the syntax for this particular nested if, and how it happens, how it is going to execute in this nested if. Let me take the syntax first. It is an extension of the if condition or if construct, where we will be having more number of if conditions. That's it. More number and one if inside another if. That is the reason why we are calling it as the nested if constructs. So the syntax will be, we have the if keyword and we have the first condition, and after that with if this let us explain the execution later, and within this if I can write another if. This is another condition, condition 2, and we can have another if condition within this if also. Like that you can go to any level like this. And finally, once this outer if is completed, you have to end it with else block. That's it. And after else you will have the statements, you will have the remaining statements. So this is the syntax of nested if. Let us see how it is going to execute. Initially, the first condition, the first if block, the outer if block, this is called as outer if block. The outer if block condition, that is condition 1, is evaluated. If the condition 1 is false, let us take the false condition first. It will immediately skip out of this entire if block from here to here. It will skip and it will execute the else block statements, and after executing the else block statement, as we know, the remaining statements of the program will be executed in a sequential fashion. Now let us see what happens if the condition 1 is true. So if condition 1 is true, then it will execute the if block, outer if block. So it will come here. Now it will check for condition 2. If the condition 2 is false, then it will come out of the else block and it will execute this block, these statements, and the remaining statements will be executed. If there are some statements before this if condition, they will be executed, otherwise it will check this condition, and then based upon this condition it will come out of the if block or it will execute the remaining things. And assume that the condition 2 is also true. This is true and this is true. Now it will go and check the condition 3. If it is true, then it will execute this block and then it will skip this block and then it will execute the remaining statements of the block. So here this is something similar to that of how when these statements are going to be executed. If condition 1 is true and condition 2 is true and condition 3 is true, it has to check all the 3 conditions. If the 3 conditions are true only, then only this block will be executed. This is the innermost if block. We can call it as innermost if block. So the innermost if block will be executed if and only if all the conditions are true. Nested if. Now let us see the other construct, that is if else if ladder, very important construct. So this is something related to if else followed by another if else, another followed by another if else, like that. That is the reason why we are calling it as the ladder. right. So let us see the construct here, the syntax of the if else if ladder. The syntax is starts with the keyword if, and then we have condition, first condition 1. We have some statements. Let me take the statements, 2 statements. We can have any number of statements, but for example purpose I am just taking 2 statements here. And then we have the else block. But within this else block also, what we are going to do is we are going to put one more if block here. That is the reason why we are calling it as if else if ladder. And let me take 2 more statements here, statement 3 and statement 4, like this. And similarly you can take one more else if ladder also, else if condition 3. Let me take 2 more statements here, statement 5, statement 6. And if we are satisfied with the number of conditions, then we have to end this if else if ladder. After this I am just continuing here. We have to end this if else if ladder with the else block. And after else block, the normal statements of the program will continue like this. How this if else if ladder is going to be executed? Similarly, the execution always starts from the outer if block. So condition 1 will be tested. If condition 1 is true, the statement 1 and 2 will be executed, and after execution of statement 1 and 2, it will come out of the entire if else ladder and it will execute statement 9 and statement 10. This is the case with condition 1 is true. So if condition 1 is true, we are going to execute statement 1, 2, 9 and 10 and so on. But what happens if condition 1 is false? This is false. So the if block is not going to be executed. It is going to the else block here. But in the else block we have given another if condition because of this else if ladder. So once the condition 1 is false, it will check whether the condition 2 is true or false. If the condition is 2 is true, then it will execute statement 3 and 4. After that it will execute statement 9 and 10. So here if the condition 2 is true, it is going to execute 3, 4, 9, 10 and so on. So when this 3, 4 will be executed, whenever the condition 1 is false and condition 2 is true. Similarly, if the condition 2 is also false, condition 1 is false and condition 2 is false. In such situation, it will go for the else block of this particular if else if ladder. So it will come here and it will check the condition 3. Condition 3, if it is true, then 5, 6 will be executed, then it will execute 9 and 10. 5, 6, 9, 10 and so on will be executed. Now what happens if condition 2 is false? This we have not discussed, right? So if condition 1 is true and condition 2 is false, we came here. We are going to test the C3. Condition 3 is tested. What happens if condition 1, condition 2 and condition 3 are false? This is false, and this is also false. In such situations, it will go and execute the else block, this one. So in such situation, statement 7, 8, 9, 10 will be executed. So this is how the else if ladder is going to work. So it all depends upon the conditions and it all depends upon the logic. What construct you want to use for the implementation of your logic, that entirely depends upon your programming skills. Nobody is going to build the logic related for a particular problem. So you can have your own logic, the other person will have his own logic. So for the same problem, you can have n number of solutions. It depends on the programming skills and the logic that is going to be implemented by the programmer. So which construct to use, whether you have to use the simple if or simple if else or nested if or else if else if ladder, all these things is purely dependent upon the programming skills and the logical ability of the programmer. When you practice more and more programs, you will be getting the logic, or you will be getting the programming skills on your own. So practice more and more programs. And the last construct related to this decision control statements is switch case. Very, very, very important concept. So this switch case statement is called as multi-way selection. This is called as the multi-way selection statement. In the previous discussion, we have seen the concept of if-else-if ladder, where the execution of the statements is purely dependent upon the conditions. If condition 1 is true, what happens if condition 2 is false? If condition 1 is true, if condition 2 is also true, what happens? All these things, those are also comes under the category of multi-way selection only. But there is a problem with that particular if-else-if ladder. Even though it is a multi-way selection, there is a problem there. That is, the program is not readable when the number of conditions increases. So the disadvantage of the if-else-if ladder is, if the number of conditions is going to be increased, the program becomes somewhat clumsy, and the program will become unreadable. So by looking at the program, you cannot understand what logic it is going to implement. So in order to increase the readability and to maintain this multi-way selection statement, the programmers or the earlier developers of the C programming language, they have implemented a simple but very powerful multi-way selection statement, which is called as the switch case statement. Let me write the syntax of the switch case, and then we'll discuss what are all the various important points that are related to this switch case. Right. The syntax of the switch case statement is, the switch case starts with a keyword called switch. Everything is in lowercase letters only. And after this, we have a parenthesis. And within the parenthesis, you are going to give an expression here. We'll explain everything, what is this expression and all these things. And after this we have to start the switch body. As we know that the body of any construct will always be started with the opening curly brace. And after this switch body, within the switch body, you have to start the thing with a keyword called case. After case, you have to give some space and then you have to specify the label. And you end it with a colon. Remember here, this is a colon, not semicolon. This is not a statement terminator. This is a colon. And within this case label 1, you can write the number of statements. Any number of statements you can write. And like that you can specify any number of cases here. So another case can be specified with the same case keyword, but you will be changing the label here. And you always end it with colon, and then you write the statements n plus 1, statement n plus 2, and so on, statement n plus m, or m, let me take it as m, example. And then I can write another label starting with case keyword. Label 3 is something different, and end it with colon, and then you can write like this, statement m plus 1, statement m plus 2, and so on up to statement p. Let me take it as p. And like this you can continue to any number of labels. So the last label, let me take it as case label n. Here also you can give number of statements, statement a plus 1, statement a plus 2, and so on up to statement b. Once you are done with all the case labels, you can include one more case which is called as the default case. So the default case starts with the default keyword, and it doesn't have any labels like cases. So after default keyword you give the colon like this, and then you can write the statements. And once you have specified all the cases along with the default, you can end the switch body and you can write the statements after this switch case. So this is how the syntax look like. Very simple thing, but it appears as if it is very tough thing. So it always starts with the keyword switch followed by an expression, and within the body of the switch you can write number of cases. Every case should start with a keyword case, and every case will have some label name. So label 1, label 2, label 3, and so on. And every case label, after every case label you have to give one colon, and after colon you can give any number of statements within the cases. Like that you specify any number of cases, and the last case you can specify it as a special case, which is the default case. This one, default followed by colon, and after default you can close the switch body and you can write the remaining statements. So this is the syntax, and let us see how this switch case is going to be executed. Once this switch case execution is completed, we will discuss different important points related to this switch case. What is this expression? We know this switch, nothing to explain about this switch, but there is something to explain about this expression. This expression can be a arithmetic expression, or or it can be a logical, or it can be some expression that gives some value, remember that this value is not equal to a boolean value. It is not the true or false. It should not specify the true or false. It should give some value. It can give a value of 10, it can give some value of 20, 2, 1, any value which is nothing but integers. So the expression should always evaluate to an integer value, or else it can also, the expression can also be evaluated to a character constant. It can be a character also, single character. So very important point, the first point about the switch case is regarding the expression. What is the important point we can write here? The expression should always evaluate an integer value, or it can evaluate to a character. Nothing more than these two values are accepted. For example, if the expression evaluates to a value like 13.5, which is a decimal value, this value is not accepted. Floating point values are never accepted as the expressions. It should always evaluate to integer or character. Next, coming to the body of the switch case, as we told that the case is a keyword which is followed by a label 1, label 2, or label names, right? Here one important point regarding these labels is second important point. You should observe here with the label names, right? As that of the expression values which evaluates to only integers and characters, you should this expression means not only expression, it can be a variable also. It can be a variable which holds the value of integer. It can be a variable which holds the value of character. It cannot be a variable which holds the value of float. It cannot be a variable which can hold string. So strings, floating point, double, they are not accepted. Only integer and character are accepted. Similar to that of the expression or the variable inside the switch, the label names should also be the integers, or they can be characters. So this label names, label 1 means you can take the integer values. For example, 1 is accepted, 2 is accepted, 3, 40 is accepted, 50, like that and so on. Any value, integer value you can take. Everything is accepted. Similarly, as I told that it cannot be a 13.5 or it cannot be a 23.456. Floating points are not accepted. In the similar fashion, characters. If you consider the characters, it will accept only characters and it is character constant. We have seen in the previous discussions that a character constant is a single character that is enclosed within single quotations, right? So it can accept a single character A and you have to enclose it within single quotations, and it can accept another character I and enclose it within single quotations. And for example, if I want to take a symbol plus, is it accepted? Yes, it is accepted. Why? Because plus is treated as a character, but you have to include within single quotation. Similarly, you want to take a division operation, right? Like this. Yes, it is accepted. The division is treated as a character, but you should enclose it within double quotations. Like that you can take any number of symbols here, character constants. So that is another second important point regarding these label names. And after these label names, you can write any number of statements like this, accepted. So that's all about this case label 2. Label 2 means again the rules for these label names you have to follow. We have statements. Similarly, case label 3, we have statements, case label n, default. Now we should discuss very important point, the third point, which is related to break statement. Here in the syntax we have never mentioned where we have to write the break, right? But while writing the syntax, at the end of each label statements, for example, if you take the label 1, we have n statements. After these n statements, it is mandatory that you include a break statement here. Similarly, in label 2 also, at the end of the last statement, you include a statement called break. After label 3, you include a statement called break. And similarly, at label n, you include a statement called break. Here, default also, you can include a statement break. Remember that first important point. Regarding break, make it a habit to include break as last statement of each case. At the end of each case, you include these break statements. You make it a habit. I'll tell you why this break is important. So if break is not there, what will happen? All these things we should discuss, right? Before this, let me explain how this case switch case is going to be executed, right? Whenever the control comes here at the switch case, the expression is evaluated and it will find the value of the expression. If the value of the expression is some value, if the value of expression is some integer, valid integer or character, then it will enter into the switch case body. For example, let me take the labels as 10, label 2 is 20, 30 and 40, like this. Let me take the expression has been evaluated to 10. The expression is evaluated to 10 or 30. Let me take it as 30. So with this expression value, it will enter into the switch body and it will check with the label. So here the value of the expression is 30 and the label is 10. Therefore, they are not matching. Therefore, this case will not be executed. Then it will go to the next label. Here the label value is 20. 30 compared with 20, it is not equal. Therefore, case label 2 is also skipped from the execution. Now it will come to the third label, which is, and it will check the equality. So the expression value is 30 and the label value is also 30. Super, right? Therefore, there is a match here. Therefore, it will execute the case label 3. Therefore, the statements m plus 1, m plus 2 and statement p will be executed. After executing statement p, you can see the break. The importance of the break statement is to come out of the construct, whether it is a loop or whether it is a if construct or whether it is a if else construct, whatever it may be. Break means you just break the execution. Break means you just break the execution and go out of the construct. So once the break is encountered by the compiler, it will break the execution. Therefore, the label 40 will not be executed, default will not be executed. The control will simply thrown to this block out of the switch case block. Therefore, you will, after executing m plus 1, m plus 2 and p, c plus 1, c plus 2 and so on will be executed. The point here you have to observe is the value of the expression is checked against each and every label in the switch case. If there is a mismatch, that case will be skipped. If there is a match, then that particular case will be executed. The statement that correspond to that particular case will be executed. Once the case statements are executed and once the break statement within that case is executed, the control will break from the execution of the switch case and it will go out of the switch case and continue its execution from the next statement of the switch case. Now we have seen why we are using break, right? Why is clear. Why we use break, very much clear. Now let us see what happens if break is not there. What happens if you don't give break? I told in the earlier class, right? Earlier discussion that please make it a habit that you put a break statement after the end of each case. Let me take an example where I didn't include this break. Now let us check. The expression evaluated to 30 is therefore 30 compared with the first case label 10, which is not equal. The statement, the case is not executed, then it will go to the next case. 30 compared with case label 20, it is not equal, therefore this case is also not executed. Now the third case, 30 compared with 30, this is very good, right? So here there is a match and the case is going to be executed. So it will execute statement m plus 1, statement m plus 2 and up to statement p will be executed. But after statement p, you can observe that you forget to give break. So what happens if you don't give break means the execution will continue to the next labels unless it comes across the break statement or unless it will execute the closed curly brace of the switch case, right? So the case is matching, 30 is matching, therefore the statement m plus 1, m plus 2 and p will be executed, but here there is no break. So what happens is the flow will go to the statement or the next case, which is case 40. Without checking the label, it will execute the statements. This is the disadvantage we have the switch case. So I'm always stressing you that you always include a break statement. You always make a practice to include the break statement as the last statement of the switch case, of any case. So here in this case what happened is 30 is matching, therefore statement m plus 1, m plus 2, p is executed, and since there is no break, the control will go fluently towards the next case. And irrespective of the value of the case label, it will not check the label. It will simply execute the statement. Therefore, after statement P, A plus 1 will be executed, A plus 2 will be executed, and B up to B will be executed. And here it has encountered a break. Therefore, it will come out of the switch case and then it will execute statement C plus 1 and statement C plus 2. For example, assume that there is no break here also. So what happens here? It starts its execution from m plus 1, m plus 2 and so on up to P will be executed, and it control will go and execute statement A plus 1, A plus 2 and so on. B will be executed. Since there is no break, the next case is also executed, default case. Therefore, B plus 1, B plus 2 and so on up to C will be executed. Here it has come across break. Therefore, the statement C plus 1 and C plus 2 are executed. So that is the importance of break. So what happens? This is a simple Viva question. What happens if you don't have a break in the case of switch cases? Means there is a free flow of execution. So the execution continues to the, if no break. This is very important question. If no break in switch cases, execution continues to other cases also, to other cases, and it will execute the statements in the other cases. This will happen until unless it comes across a break statement, or it will this execution or the flow continues to execute the other statements in the other cases until it comes across the closed curly brace of the switch case. Either it has to come across the break or it has to come across the closed curly brace. This is the importance of the break statement. Very, very, very important. And the last thing, we have explained what is this switch, we have explained what are the values of these expressions, what is this case. This switch and case are nothing but the keywords, and what are these labels, what are the accepted values of the labels like the integer constants and the character constants, and the importance of break has been discussed. And the final discussion is on the default keyword, default case, small letter. You can see here that the default case is there. What is this default? As the name itself indicates that this default case will be executed if none of the labels are matching. If none of the labels are matching, the default case will be executed. That means, let me take an example. Let the expression be evaluated to 50. With this value of the expression, it will enter into the switch body of the switch case, and it will check with the first label 50 compared with 10 not matching. 50, then it will go to the next case. 50 compared with 20, there is no match. Then it will go to the next label 50 compared with 30, no match. It will go to the next label 50 compared with 40, no match. Therefore, there are no labels that matches the expression value. In such situation, it is going to execute the default case. So the default case is a special case which is executed by default if none of the labels of the switch case, if none of the labels are matching with the expression value. So here none of the labels 10, 20, 30, 40 is matching with the expression value, that is 50. Therefore, the default statement or the default case will be executed, that is statement b plus 1, b plus 2 and c will be executed, then c plus 1, c plus 2 will be executed. But in general, the default case, remember one important point regarding default. So in general, the default case will be given or used to express the error condition, or to say that none of the labels have been matched with the expression. That is called, you are giving some information about the error to the programmer or the user. So the default case is in general. It's not mandated that you should always use it for that error, express the error conditions only, or error messages only. You can also make use of it for different purposes also, but in general we will make use of the default to tell the user that an error has been happened here in the switch case. This is all about the default. And one important point, you should know why we have to use this switch default. Why means, if none of the case labels matches with the expression value, then the default case will be executed. That is the reason you have to give. And there is another question at with this default. In general, it is a practice to give the default as the last case. As the last case. At the end of all the cases, you will specify the default. But is it mandatory that you should always specify the default as the end case label? The answer is no. It is not mandatory that you always specify the default as the last case. You can put the default anywhere in the switch case. Anywhere you can keep. So if none of the labels are matching, then it will go and check whether the default case is specified somewhere else or not. If they are specifying the default case, then that default case will be executed. Therefore, you can put the default as the first case label, as the first case, or second case, third case, fourth case, anywhere you can put the default case, right? So don't be in an assumption that you always put the default case as the end case of the switch case. You can put the default anywhere. The compiler will take the complete responsibility of executing the default. If none of the labels are matching, it will directly search for the default and that particular case will be executed. So you don't, as a programmer, you don't have to worry. Everything will be taken care by the compiler. So that's all about this switch case. Everything about the switch case is discussed. What are the important points regarding the switch case along with the syntax. So that's all about the switch case, right? So in today's class we have discussed about the sequential execution of the C program and how we can violate the sequential execution of the C program by using the conditional control statements or the decision control statements. In this we have discussed 5 important constructs related to this decision control statements. One is the simple if else, nested if else if ladder, and finally we have seen the switch case also. All these constructs along with the syntaxes and some of the programming examples we have seen in today's session. That's all for today's session. Thank you one and all for joining. In the next session we are going to discuss about the other control statements which are called as the looping statements. Thank you.